Today we're going to look at leveraging Microsoft Azure and Kemp's LoadMaster to build a hybrid cloud solution. In this demo environment, we have Exchange 2013 running on-premise, and we're making the move to Office 365. Since we're looking at leveraging domain accounts to authenticate to Office 365, we decided to deploy Directory Synchronization and Active Directory Federation Services, ADFS. Since ADFS must be available in order to authenticate and access the Office 365 services, we're required to provide not only high availability for this component, but also site resilience. The existing on-premise environment consists of two ADFS servers being published and load balanced with a Kemp virtual LoadMaster running in our Hyper-V environment. We have an Azure subscription and established a site-to-site VPN between the two environments. The Azure environment includes a domain controller to extend our Active Directory to the cloud in the event we lose our on-premise data center. An additional ADFS server was created in Azure to provide that site resilience we require. Finally, an Azure LoadMaster was deployed through the marketplace as our final building block of this solution. The virtual LoadMaster on-premise and the virtual LoadMaster in Azure were configured with our GeoPack, or commonly referred to as Global Server Load Balancing, or GSLB. With Geo, the Kemp LoadMaster is responsible for answering DNS queries from clients for the ADFS services. So when a client attempts to access adfs.kempdemo.com for authentication, the LoadMaster will provide an IP address of an ADFS server which is available. Plus, additional configuration can be done which can allow the LoadMaster to provide an IP address for a service based not only on availability, but also on the user's proximity. In this demo, we have all ADFS traffic being directed to on-premise for authentication. We're going to simulate a failure of this environment and direct all traffic to Microsoft Azure. Of course, the environment can be switched to have the Microsoft Azure as the primary location as well. Let's take a look at this solution in action. So the first thing I'd like to demo is the creation of a virtual LoadMaster for Azure through the marketplace. So simply go into the marketplace, and there's a few things you can do. You can scroll down in the marketplace and select the Kemp LoadMaster, or just simply search for Kemp. Now, you're going to get a few options available here. These are going to be based on throughput, on transactions per second, etc. So you really want to select the LoadMaster which best suits your requirements. So we'll go ahead and create, and give it a name, username, password. And we have other options here. We can go ahead and select the network. So we're on the same network as our ADFS server and domain controller, the one that's connected via the site-to-site VPN. So let's go ahead and select that one. This one's on the 192.168.20 network. Okay. Select create, accept the legal terms, and purchase. So you'll see that the Kemp LoadMaster is being created. Now we have one that's pre-configured, which we'll show you just in a bit. So let's go ahead and take a look at the networking component within Microsoft Azure. So we have our Azure Network, which is our 192.168.20, and then we have our Azure Local Network, which is 192.168.10, which is on-premise. And then we have our site-to-site VPN between these two environments. So here within Azure, you can see the virtual machines we have set up within the Azure network. We have our domain controller, we have our ADFS server, and we also have our LoadMaster, which was deployed through the marketplace. So if we go over to the LoadMaster within Azure, so our Azure LoadMaster, we can go through and kind of look at the virtual services we set up for ADFS. So virtual services are really just a virtual IP address, which is publishing the actually ADFS server within Azure. Now this virtual service is real simple to set up. We actually have templates for a lot of workloads that help deploy these virtual services with just a few clicks. Now if we go over to our Hyper-V LoadMaster on-premise, we'll see we have quite a bit more virtual services. Here we have Link, we have Exchange, we have the Office web app servers, as well as our ADFS server, which is once again publishing the two servers on premise, the ADFS servers on premise. Now, part of the configuration to get that global load balancing set up is we created a fully qualified domain name for adfs.kempdemo.com, and we've added the two public IP addresses, the 66.252 address, which is on-premise, and the 23.101 address, which is in Azure. And as you can see, both of them are available at this time. Now, this configuration, once again, we're looking at the Hyper-V on-premise, is mirrored on the Azure. So if we go over to Azure, the global balancing, once again, we're seeing the same configuration with the same IP addresses. This will allow clients to get queries from either load balancer. So you have, once again, that high availability and site resilience. So let's go ahead and take a look at this. And if I do a ping to adfs.kempdemo.com, I'm getting, once again, the 66.252 because this is what we're using as our primary data center. So if I go ahead and launch a browser and log into Office 365, I'll be directed to our ADFS farm on-premise. So if I do a netstat, we'll see we're connected to 66.252, which is our on-premise environment. And if I log in, we're authenticated and we have access to Office 365. Can open up Outlook web app, and everything works great. So let me sign out of this browser. Close that. Now what I like to do is I like to simulate what could be a full data center outage. Right. So what we can do is go to the on-premise Hyper-V environment. We're going to go to our ADFS service, and we're simply just going to deactivate this service. So as you can see, it is now disabled and no longer going to be able to service clients. So as we go back to global balancing, you'll see the availability of this service has changed to a down state. So if we go back over to our command prompt and we ping adfs.kempdemo.com, you'll see the IP address has changed to the 23.101 address, which is in Azure. So let me launch my browser. Once again, log into Office 365. And we'll once again get an ADFS form. And now if we look at 23.101, we'll see we have actually an established connection on that IP address and not on the 66.252 address. Once again, can log in. And we have access to Office 365 and once again launching Outlook web app. As you see, combining Kemp LoadMaster on-premise and the Kemp Virtual LoadMaster for Azure with the Azure Networking platform, we're able to create a highly available hybrid solution to authenticate to Office 365 with site resilience regardless of outages. You can find more information about Kemp Technologies at www.kemptechnologies.com or contact Kemp's Global Director of Strategic Alliances, Joshua Lee, at jlee@kemptechnologies.com.